be using the apparatus called the Gaseous Diffusion apparatus, which we'll use to calculate the diffusion constant for the two liquids which we're using, which is the acetone and methanol. The acetone will be conducting in two temperatures, which is 40 degrees and 50 degrees, and we'll be comparing the effect of the temperature on this constant value. Now in this apparatus, this is the vernier calipper which we'll use to calculate the change in the length, which we'll see with the help of this microscope. Now through this microscope we'll see an inverted meniscus. We're using this air pump for a continuous flow of air so that the concentration of the acetone at this point remains zero.
So to measure the change in length of the meniscus, we've decided to use a 15-minute interval, at which point we will get at each point and plot the graph.
Good morning everyone, my name is Zafa and I'll be talking to you about our mass transfer project, gaseous diffusion of volatile liquids into air. To start off with, the reason why we chose this topic is because the diffusion of volatile and hazardous components is an inhalation of them by humans can be a very severe problem and can cause many health issues. That's why it's important to know the volatility of different components, and also it's important to know the diffusion rate and how it can be obtained. In our experiment, we tried to observe the effect of volatility of two different liquids, acetone and ethanol and acetone, and also we tried to find the effect of temperature on the diffusion coefficient using acetone. Okay, the materials and methods. The materials we used for our experiment, we need a gaseous diffusion apparatus, we need liquid acetone, the liquid ethanol. We also needed a vernier caliper to measure the change in the meniscus. We also needed water to fill the we needed water as the solvent. Also we needed we had constant and steady air passing through the apparatus to facilitate the diffusion. Thank you.
Hello, my name is Marwa and now I'll be talking about the experimental setup. To start this experiment, we're using the gaseous diffusion apparatus, which is right here. The first step is to fill up the water bath of the gaseous diffusion apparatus and set the heater to 50 degrees Celsius to heat the water up. The second step is basically fill the capillary tube with ethanol and tap the capillary tube to make sure there are no air bubbles within it, and then use the vernier caliper to measure the Z note to measure the initial length of the diffusion path, Z note, with the help of the vernier caliper. That's the third step. For now, we connect a hose to one end of the TPs to provide a continuous flow of air. And then the fifth step is to adjust the vertical height of the microscope. And finally, we have to switch on the pump, start recording the level, drop from Z to Z node using the sliding vernier caliper at each time interval. Thank you.
Hi, I'm Abdul Majid. Now I'll talk about the results and discussion. We started off the experiment using ethanol as our solute, and we measured the change in level of the ethanol every 15 minutes until we got 5 readings. And we used 2 different temperatures to get these readings. Since the ethanol has a high boiling point, the change in level of ethanol is really low. Therefore, we had to use acetone as our solute for the next trial. Acetone gave us a good change in level for the same time interval. Using the values we got for the change in level, and using this equation, we found the coefficient of diffusion, or the diffusion coefficient. Using the values for the change in level we got, and using the time, we plotted a graph of change in level squared versus time. We got a linear relationship, hence proving the equation is right.